In this video, I'm going to show improvements I've made to power distribution on my breadboard. I've also added a bus board, a PCB, to extend my address and data lines. And I have tapped into that set of address and data lines on that bus board with an Arduino. And I'm using that Arduino as a really basic logic analyzer. And I'm going to show you all that in this video. So first things first, you can see that the system's booting up here, and I've modified the code a little bit, and I thank everybody for help on some assembly recommendations and just general help that I've received to maybe clean up some of my code. So thank you everybody that's been helping me with that. You'll notice here that the system is running right now with an effective clock speed at the processor of 5 megahertz. I have an oscillator up top in the reset clock card that's running at 20 megahertz. That is being halved as it leaves that card because I run it through a flip-flop. So going into my processor is 10 megahertz, and then the processor halves that for its own processor clock, and that means I'm getting an effective 5 megahertz processor at this point. And things are running well, even again with this mess of wires coming off of my processor, going all over the breadboard, over to this new board to the right, and all the way up to the Arduino. So I'm pretty happy with that. The other changes I made, you can see I've pulled the LED bar graphs off the breadboard. There just simply wasn't enough room for me realistically to tap in to get over to this new bus board off to the right. So I'm just using the LED bar graphs on that bus board. This is just a generic bus board I had put together quite a while ago. You can see that it accommodates this 40 lines. So I got my 24 address and my 16 data. So it accommodates those 40 plus some power, I guess, and ground, and a couple other signals if I want to put them on there. But really all I'm using it for right now is the address and data. So I made room by the processor. I pulled those signals over onto the board. They're just connecting to pin headers. And then you can see the bar graphs up top. At the very bottom of the bus board, I do also have options if I want to put in some sort of pull up or pull down. And the way I've set up this board is I can just with a simple a jumper either have it be pull up resistors or pull down resistors, and I've got sockets so I can put in resistor SIPs and play around with different values of pull up and pull down. But at the moment I'm not leveraging that at all. I did lower the resistance. No, sorry, actually I increased the resistance with those LED bar graphs with those SIPs just because I wanted to put a little bit less stress on that processor that's driving all of that. So you'll see that they're a little bit dimmer, but as I look at it in person, it still looks perfectly fine. And then I've got the Arduino tapped in. Pulling all the address, pulling all the data lines, it's pulling all of the signals coming out. Anything that you see an LED on the board, I guess, as far as am I reading or writing ROM, RAM, whatever it might be. And then also those same signals, the COD, int A, MIA, S1, S0, I'm pulling all of those in also. In the upper left, you'll see that I've pulled in one of my previous PCBs. It's just a utility PCB, kind of like my reset clock. It's just a power distributor PCB. So it takes a DC barrel connector coming in. You know, I just show the voltage I'm receiving coming into that. I've got some capacitors there. It's not doing anything fancy. It's just capacitors there. And then I have a variety of different types of connections that I can run from it. And I'm again using these quick connect green connectors. One goes down to the breadboard, and again that's connecting to 10 pins down there, 5 pins for 5 volt and 5 pins for ground. I've got another power connector running over to my reset clock card and another power connector running over to that far right bus board. I am getting a clean voltage across all of the breadboard and all the way down to the lower right of the breadboard and that bus board. So my voltages are looking pretty good. So I think it's doing what it needs to do at this point. And here I have basically reset the system. I've switched the reset clock card over to a 555 timer instead of the oscillator, just so it's slower. And you can see I'm showing this logging output of the Arduino. And so I'm showing the address in the data lines bit by bit. I'm also showing it in hexadecimal. And then I show the value of all of those output enable indicators in the next 6 lines or 6 columns. And then the last 4 columns are those standard signals coming out of the processor. I think this is going to kind of help me as I get in and have to do some more debugging. I've got interrupts on my to-do list that I'd like to start playing around with, and a couple of things that I am looking to be able to do here is A, be able to let this run so that I can really understand what's happening with the different signals and such. But B, I think I'm also going to add support so that the Arduino can drive the clock, and that way I can have it basically break or stop the clock under certain conditions. So I can say look for a certain value on the address or the data bus, and if you find it, then go ahead and stop the clock. Or I could also say go ahead and run the clock for 50 cycles right away so that I don't have to wait through that normal startup of the processor and then have it stop and let me go into a step-by-step mode. I don't know, I'll play around with that. That's just an idea in my head at the moment to maybe make debugging easier as I move forward. So as far as the Arduino code, it's pretty simple. I'll just scroll through it here so you can take a look at it. But essentially I'm just making a couple of arrays. What are all the different pins I'm going to use for my address and my data? What are the pins for clock? All those different basically enable signals, RAM read, RAM write, etc. And then those 4 coming out of the processor, caught into MIO, S1, and S0. And the setup, I'm just basically saying these are all input pins, and I set up an interrupt. So every time the clock fires or the clock rises, I'm going to go ahead and run some code. And that code is then in this block here. And that's the entirety of this monitor. And all I'm doing in here basically is reading the bits. Every clock beat, I'm writing them out. And then I'm adding to that raw output a hex version of it, and then the status of all these other indicators besides address and data. And that's it. So very simple as far as the actual code is concerned there.